Okay, there are a simple example. For example, this is for the multiplexer. You can write this example and you can run it in your Quartus. It's very simple. One more point, let me tell you, you can add a delay to your circuit. Actually this circuit is the same as the before example, but we have something different. Module, the name of the module, we write the name of the module, the circuit with delay. Actually the name is up to you. Our input and output, and we define our input and output here separately. We define our write everything like a previous one, but here we have something else. We use one syntax sharp and one parenthesis and something here is a number. Okay, it means that we can add the delay. It means that this gate running but after this delay, or this gate running but after this delay, so we can add delay to our circuit. For example, when the input and output reach to this gate, for example, stop 13 seconds or 30 milliseconds or something like this, and after that run this gate and set the output. Okay, so we can add the delay for our function. Another example is another latch form. Okay, this is again with the always, so it's behavioral, and the name of the module is the data latch, latch. Sorry. The input and output, we define our input and output and our register here. Always D or clock. It means that if something happened to D, our input, or something happened to clock, it means that the clock reached to our circuit. Always function begin to run. Okay, so and also here we check the if. We use the if to check the clock. It means that we should have a clock if we are going to assign D to the Q. Okay, so always check the clock. If the clock is okay, it's fine, we reach the clock, and we can assign D to the Q, so the input will reach to the output. It's a D latch. And this is another one, the D flip-flop, but it's different from here and here, and you can find what's the different. Why? Because here in the condition everything is the same. For example, module, the module name, our input, output, register, but here the condition is different. Yes, because we check the post age of the clock, positive age of the clock. If you remember from here, we check that this area. Okay, this area. Sorry, I know that I'm very bad in the painting. Okay, so we check the positive edge of the clock. If the positive edge of the clock is clear, that's why we go to the always block and we assign D to the Q, D to the output. And another and last point of the Verilog language is this one. Actually, just check this circuit. You have input, you have output, you have a register. Again, we define module, the name of the module, our input and output port, our input and output, and our register. You can see the output and the register are the same, and always check the positive edge of the clock. So this is the clock, and we check the positive edge of the clock, and this is begin and end. Okay, whenever this happen, go to this part, begin, and assign D to the Q and assign Q1 to the Q2. Okay, but this is the same as this one. You can check this code, everything the same, but this symbol is different. Okay, both of them are assigned, but what's the difference between this one and this one? Okay, if you check the circuit, you can find out what's the difference. Okay, check this series and check this parallel. Okay, yes, they are parallel, so we can down it in the parallel or any order. Okay, so it can run it in the parallel manner. Okay, but here it's a series execution. Okay, so it's a different with when you write the call and you write the call and bigger than. Okay, so it's different. It's non-blocking assignment, and this is the blocking assignment. You can find the difference in the picture as well. Okay, and okay, the last one is up to you. It's not important. I tried to put this one in